Okay, welcome to the last 7 pages of everybody's favorite packet, solutions. This is the 9th pack of the year. We're going to finish the last 7 pages. This first video will be just pages 27 and 28. Okay, so we all know by now what a percent is, yes? All right, let's just review that. We know from percent composition, it's mass of part over mass of whole times 100. Anything that's percent, you must always times by 100, just like in percent error, we times by 100. So now for this packet, we're going to do the percent mass of a solution. All right, so again, it's always part of the whole. Wait, doesn't the solution have 2 parts? Yes, we have the solute, which is what gets dissolved, and we have the solvent, which is what does dissolving, the water. Right? So we always have the little numbers always be solute. You always have less solute than you do solvent. Right? So solute plus solvent gives us our whole, which is the solution. So be careful now. When people make the mistake, the whole is not the solvent. The whole is the solution, which is solute plus solvent. All right. So let's write the form on the board for the top of page 27, percent by mass. Okay. It says formula table T, but it's kind of the same formula as this, but we're just going to change it around a little bit. So the formula is for percent mass. Okay, again, it's mass of part, but the part is the solute. Mass of solute. That's our part this time. And the whole is the solution, right? So it's mass over mass of solution times 100. Okay, so it's not mass of solvent, it's mass of solution. Remember, the solution is the whole. It's solute plus solvent. Right? Remember, solute plus solvent is the same thing as solution. Okay? All right, so you got to make sure you add your grams for both. All right, so let's do number 1 together. Number 1 says, what is the percent mass, again, it's page 27, what is the percent mass of sodium hydroxide of 2.50 grams of NaOH are added to 50 grams of H2O. Okay, so we know our solutes can be the lesser number. So what was the percent mass of sodium hydroxide of 2.50 grams of NaOH, which is the sodium hydroxide? So that's our part, 2.50. Now it says we add to 50 grams of water. So is 50 grams our bottom number? Is water our solution? No. Water is our solvent, so you don't put 50 down there. Again, for the solution, you have to add the 2 numbers together. So you have to add 50 plus 2.50 to get a bottom number. So it's going to be 52.50 that goes on the bottom, times 100. Now, if it said 50 grams of solution, then you could put 50 down there. But if it just says 50 grams of water, yeah, you can't put that. That's just a solvent. So the solution is solute plus solvent, which is 52.50. So you just do your math, 2.50 divided by 52.50 times 100. You get 4.76%. Okay, so that's number 1. Okay, now I'm going to skip number 2 briefly. You're going to do that one on your own in a minute. I'm going to skip down to number 3, which is you're solving. The number 3, you're going to be solving for mass of solute. Okay, they never ask you to solve for mass of solution. Right, so those guys solve for mass of solute. Okay, so we'll do number 3 now. So number 3 says you have 1,500 grams of a bleach solution. So that is the whole entire solution. It says solution. You have 1,500 grams of a bleach solution. The percent by mass of the solute, sodium hypochlorite, NaOCl, is 3.62%. So they give you the percent. How many grams of NaOCl are in the solution? So let's set it up. So they give us our percent by mass, which is 3.62%, equals, okay, we're solving for mass of solute, and they give us 1,500 grams of a bleach solution. So 1,500 grams is our mass of solution. And don't forget R times 100. Okay, so to get the mass of solute, you have to get X by itself. All right, so the first thing you want to do is, remember, this 100's attached to this, so you got x over 1,500, you got times 100. So you want to get this x over 1,500 by itself, so we get rid of this 100 by dividing by 100 on both sides. So this cancels out. You divide 3.62% by 100, which is just basically moving the decimal over 2 places left, which is 0.0362. Just move it over 2 places left, 0.0362. So now let the 0.0362 equals x over 1500. So what I do next? Cross multiply. This over 1, just cross multiply. 0.0362 times 1500 will give me my answer. And you'll get 54.3 grams for number 3. Okay. All right, so now I want you to pause the video and try numbers 2 and 4 on your own. Okay, numbers 2 and 4 should be just like number 1. The answer for number 2 is 3.23%. Number 2, the answer you should have is 3.23%. You should have done 20 divided by 620. Okay, notice that it says 600 milliliters of H2O. Just want to make a note. You might want to make this note. 1 milliliter of water is the same thing as 1 gram of water. That's an important note to keep in the back of your head. All right, so milliliters and grams are the same thing when it comes to water. That's how they came up with the milliliter. They said, let's see how much 1 gram of water weighs. And when they got 1 gram of water, they call that 1 milliliter. All right, so 1 milliliter, 1 gram are the same thing. So 1 milliliter of water has a mass of 1 gram. So when it said for number 2, 600 milliliters of water, that's 600 grams. So you got to do 20 over 620 times 100. Right? You got that answer, 3.23. Right, for number 4, the answer is 3.47%. Okay, you have to do 3.6 divided by 103.6 times 100. You get 3.47% for number 4. Okay? So now we're going to move on to page 28, which is percent volume, but first you have 3 regions questions, numbers 5, 6, and 7. So let's pause the video again and try numbers 5, 6, and 7. Read that reading passage and do numbers 5, 6, and 7. Okay, number 5 says, okay, show the setup, express as percent by mass. For calculating the concentration of sodium ions in the sports drink, expressed as percent by mass. Okay, so you have how many sodium ions do you have? 0.055 grams, the last sentence of the reading passage. 0.055 grams. And then you have 250 grams serving. So that's the solvents you have to add together. You get 250.055 on the bottom times 100. So that is your setup for number 5. Number 6 is a throwback question from the first packet. Describe the transfer energy. Usually talk about heat energy. This is transfer energy between the skin and the surroundings as a person perspires and the sweat evaporates. Okay, so usually when you're sweating, it's because you're a lot hotter than the surroundings. So the heat flows from your skin to the surroundings is the correct answer. Heat flows from skin to surroundings. Okay, and number 7, state why salts in sports drinks are classified as electrolytes. We're going to get to that later in the year. Be sure you know they contain dissolved mobile ions which conduct electricity, just like any ionic compound. When they dissolve more, they split up in ions, they move around, which conduct electricity. So the answer should be the solutions contain dissolved mobile ions which conduct electricity. And number 8 says draw a Lewis-Dot diagram for one of the positive ions lost by the body as a person perspires. So it says potassium ions and sodium ions are lost by the body in the very first sentence. Those are positive ions. How many dots does a positive ion get? Who remembers? 0 dots. So all I have to do is write symbol for sodium and the charge, which is +1, or K +1. Remember, the negative ions get 8 dots in the bracket. Positive ions get nothing. Just write it like that. Just write the symbol. Okay? All right, so now we can move on to percent volume. So everything is still the same. We're just changing the word mass to volume. So instead of mass of solute over mass of solution, it's just going to be volume of solute over volume of solution. It's the same exact thing. So you write this for your formula. change this to volume also. Percent volume equals volume of solute over volume of solution times 100. Together, again, remember we got to add solute and solvent together to get solution, unless it says otherwise. Okay, so I'm just going to do number one. All right, number one. Was the percent by volume of alcohol at 50 milliliters of ethanol is diluted with water to form a total volume of 300 milliliters. So you see how it says total volume of 300 milliliters? That means they added it together for you already, so you do not have to add 350 in this case, because it says total volume of 300, so that's the total volume of the solution. So we can just simply do 50 over 300 times 100, and we get our answer of 16.6%. Okay, now numbers 2 and 4, there's some tricks to them, try those. And number 3 is like number 3 on the other page, the last page. All right, so let's take a minute, pause the video, and try numbers 2, 3, and 4. Okay, number 2. Number 2 does not say total volume. It says 35 milliliters of ethanol dissolved in 115 milliliters of water, so you have to do the adding. So number 2, you have to do 35. If you add 150 and 35, you get 150 times 100, and you get 23.3%. All right, number 3, you're solving again for volume of solute. All right, so the number 3, they give you the percent, 30% equals X over, they give you 100 milliliters of solution times 100. And look at that, 100 and 100 cancel out, so the answer is just going to be 30. X equals 30 milliliters. Okay. You could have done it the long way, divide by 100 both sides, multiply by 100, you're still going to get 30. Right, now, what's tricky about number 4 is they give you 1.1 liters of water. Okay, we have to have milliliters. And we have grams and milliliters, which is the same thing. You can't have it in liters when you do these problems. Okay, so you have 24 milliliters of solute and 1.1 liters. How do you convert that to milliliters? 3 places to the right. All right, so remember molarity, we go 3 places left, milliliters, liters. Now we're going backwards, liters to milliliters. So it's 1,100 milliliters on the bottom. All right, just divide the 2 times 100, and you're going to get 2.14%. Okay? All right, so please email me any questions you have on volume of percent volume or percent mass. All right, they're not very hot Regents topics, but I still want you to know them. All right, for your worksheet and for your take-home test coming up. All right, so this concludes video 1. All right, so check back in for the next video on parts per million, which is much more important.